13.1 Vector functions. Vector functions are functions where every point on the function represents an associated vector. Vectors are quantities that are defined by a magnitude and a direction. The magnitude represents the size of the vector, the length, and the direction represents the orientation of the vector in space. Vectors are written in these forms. The first form takes a similar appearance to a traditional coordinate, where the x and y values are put in parentheses. However, with vectors, we do not use x and y, and the vectors are surrounded by angled brackets instead. The second form represents the component vectors being added together to form the final vector. However, they are not in the same plane, so they cannot be combined completely. Thus they are written in the expression form instead. The letters I, J, and K represent the coordinate variables x, y, and z in vector form. The arrows above I, J, and K also show that the letters are not variables, but rather that the expressions preceding them are vectors. Vectors can also be made up of a different number of components, depending on how many dimensions the vector exists in. It could be 1 or 3 dimensions. In this case, include the correct number of components in the vector. For example, if the vector was only one-dimensional, only have one component in the vector. Vectors have domains and ranges similar to functions. Traditionally, the variable used for vectors is t, for time. The domain is any value of t that returns a defined vector value for the vector function. The range is all possible values of the vector. Vectors can also be added or subtracted. If two vectors are being added or subtracted, add or subtract the corresponding components of the vector. For example, add the I components of the vector, or the j components of the vector, or the k components of the vector. Then, write the new vector using these added components or subtracted components. For example, if we are adding the components r of t and p of t to create the vector a of t, this is how we would do it. We can also find limits of vectors. To find the limit of a vector, or the value of the vector as t approaches a value from the left and right, take the limit of each vector component individually, and write the final limit in vector form. We can also find the magnitude of a vector. The magnitude of a vector is the length of a vector, as mentioned earlier, and is written in this form. We can find the magnitude of a vector using the Pythagorean theorem. So if we think of each component of a vector as a side of a triangular pyramid, where I and j form the base legs and k forms the height, the Pythagorean theorem can help us solve for the diagonal, which is the magnitude of the complete vector. This can also help us visualize better how vectors appear in space. They can appear in 3D space and are made up of multiple different components. In this case, the I component, j component, and k component. When finding the magnitude of a two-dimensional vector, think the vector as forming a triangle instead, and use the Pythagorean theorem in the same way, finding that the hypotenuse is the final magnitude of the vector. If the vector has one component, then the magnitude is just that component. We can also graph vectors. To graph a vector, think of each component of the vector as its own parametric equation associated with the x, y, or z axis in the coordinate system. Then we just plug in values for the variable and determine the values of the vector and graph it in this three-dimensional or two-dimensional space. Vectors can also represent real-world quantities. The common example is the position of an object at any time t. We can use vectors to find the position at any time t by using the t-value and the parametric equations that make up the vector. If we were to graph all of the values of the vector components using various times t, we could find the path that the object takes over time. This is an example of a practical application of vectors.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!